Welcome to Engineer's Mindset. Now I'm going to take you through Physics 2022 Jamb past questions. The first question says, which of these is a derived unit? Option A gave us kilograms, option B meters, option C newtons, option D seconds. Okay, first of all, there are three basic quantities in physics. We have three basic fundamental quantities in physics, and they include the mass, signified by capital M, the length, signified by capital L, and the time, signified by capital T. So the three of them makes up what is called the MLT system of measurements. Okay, the unit, if these are fundamental quantities, then it means their unit is going to be called fundamental units. Okay, so the fundamental units include the unit of mass is kilograms, the unit of length is meters, and the unit of time is seconds. So these are the three fundamental units. Every other unit outside these are called derived units. So the question says which of these is a derived unit, and on the options we have kilogram. Kilogram is a fundamental unit. We have option B, which is meters. Meters is also a fundamental unit, and option C, which is Newton. Newton is not a fundamental unit, hence it's a derived unit. So the correct option is option C. Question 2 says a bar magnet is divided into two pieces. Which of the following statement is correct? Now I'm going to pause the video here and I will display the options again for you to get down the options. So when I unpause, I'll go straight to the answer. Yes, so the correct option is two new magnets are created. How? Let's say we have a magnet, and usually magnets have what is called the North Pole and the South Pole, and I decide to split this magnet into two. That means I'm going to have now this, and I'm going to have this. Of course, two new magnets are created with different North Pole and South Pole, North Pole and South Pole. So the correct option is option A. Question 3 says, consider the wave equation y equal to 5 millimeter sine open bracket 1 centimeter to the power of minus 1x minus 60s to the power of minus 1t. Question says the wave number is, so we are given different options. Option A 0.1 per centimeter, option B 10 per centimeter, option D 1.0 per centimeter, option D 2 per centimeter. Okay, for a sinusoidal wave, the wave equation is given as y equal to a sine ks minus omega t when there is no phase angle. This is a wave equation. So if we compare this equation to the given equation, in the given equation we have y equal to 5 millimeter sine, we have 1 centimeter raised to the power of 1x minus 60 s to the power of 1t. If we compare this equation, y goes for y, it means that amplitude simply stands for 5 millimeter, sine for sine. It means now that k, which is our wave function, actually stands for 1 centimeter. So that simply implies that k is equal to 1.0 per centimeter. Okay, k is called the wave number. K is called the wave number. So the correct option is actually option C. Question 4 says an object 40 centimeter high is 30 centimeter from a pinhole camera. If the height of the image formed is 20 centimeter, what is the distance of the image from the pinhole height? The options given are option A 15 centimeter, option B 70 centimeter, option C 40 centimeter, option D 40 centimeter. I guess this was an error. Okay, now let's say this is the pinhole P. And then we have an object in front of this pinhole the height of the object was given. So this is an object. The height was given as an object 40 centimeter high. So the height of the object is 40 centimeter, and this pinhole sees this object and produces an image on the other side of the camera. So this is the height of the image. So this is the image height. It wasn't given. Let's use hi. Okay. Produce 40 centimeter high is 30 centimeter from a pinhole. So they said an object 40 centimeter high is 30 centimeter from a pinhole camera. So this is the object. The distance of the object from the camera, okay, from the pinhole camera, is actually 30 centimeter. Okay, if the image formed is 20 centimeter, what is the distance of the image from the pinhole? So distance from image is what we don't know. So the image formed is at a height of 20 centimeter. If the image form is at 20 centimeter, so the image height is 20 centimeter. All right, but the image distance is what we don't know. So let's use di or di to represent image distance. Okay, of course object height is given, so let's use ho for object height. O stands for object, h stands for height, and hi for image height. Okay, do stands for di stands for image do stands for object image object distance, while di stands for image distance. I stands for image, o stands for object. Now from magnification is simply given as, okay, let me turn the book around. Okay, let's use here. Magnification is simply given as image distance or object height all over image height is also given as m for magnification is also given as object distance all over image distance. So let's simply say the two equations are definitely equal. So magnification is equal. So let's use for object height, let's use ho for object height, and image height is simply hi. So this is simply saying ho all over hi is equal to, also magnification is also given as object distance, so we'll simply use do all over image distance di. So this is actually do all over di. So they are asking us to find the image distance from the question. The image distance is unknown, di, so that's what we have to look for. So simply make di subject of the formula. If we cross multiply, we are simply going to have that hi multiplies by do, and that's equal to simply ho multiplies by di, and we are looking for di, which is the image distance. So divide both sides by simply ho. So that simply implies that di, which is the image distance, is simply hi times do all over ho. Okay, so di image distance is simply hi stands for image height times do stands for object distance all over object height. Ho stands for object height, and that's equal to, so obtain the image height. The image height was given to us. This is the image height. It was given as 40 centimeters, so we'll have 40 multiplied by object distance. The object distance was given as this is image height. Okay, so hi stands for image height, and image height is simply given as 20 centimeter. That's hi 20 centimeter, so we'll have 20 centimeter, okay, times the object distance. The object distance was given us 30 centimeter. Okay, so we'll have times 30 divides by the object height. The object height was given us 40 centimeters, so divides by 40. So this is actually 20 times 30 is 600 divides by 40. So that means that simply implies that the distance of the image from the pinhole camera is simply 600 divides 40. So the correct answer is simply 15 centimeter. And the option that bears 15 centimeter is option A. So the correct option is option A. Okay, so all you need basically is just the the magnification formula. The object height all over image height equals object distance all over image distance. You make the image distance substitute the formula by simply cross multiplying. So you have this equation. So from here you can be able to solve and get your option. Question 5 says a bar magnet is placed near and lying along the axis of a solenoid connected to a galvanometer. The pointer of the galvanometer shows no deflection when. So I'm going to pause the video here and I will display the options. When I get back, I will just tell you the answer straight. Alright, okay, so when there's no relative motion between the magnet and the solenoid, then the galvanometer will remain, the pointer of the galvanometer will not deflect. Hence, the correct option is option B, when there is no relative motion. Okay. Question 6 says tires are threaded to. Option A says increase weight of tires. Option B, increase friction. Option C, increase its longevity. Option D, look good. Well, the essence of threading a tire is actually to increase its grip to the ground while on rotary motion. That's why while a vehicle is moving, is just to increase the grip of the tire to the ground, and that increase in grip simply means increase in friction. So the correct option is increase friction, which is option B. Question 7 says a car starts from rest and travels a distance of 40 meters in 10 seconds. Calculate the magnitude of its acceleration. Option A says 3.20 meters per second square. Option B says 0.25 meters per second square. Option C says 0.80 meters per second square. And option D says 4.00 meters per second square. Alright, so I'm going to show you how to do this. First of all, the car starts from rest. When a car starts from rest, it means the properties of motion at rest is 0. So initial velocity or initial speed of the car, u, is equal to 0. Also, it covers a distance, so distance traveled, which is s, is given as 40 meters, and the time taken to cover this distance, time t, is actually 10 seconds. So we employ Newton's law of motion since the car was in motion, and we simply employ the law s equal to ut plus 1 all over 2 at squared. Now, since u is 0, the initial velocity is 0, it simply means that automatically ut, because this becomes s equal to u is 0, so you have 0 times t plus 1 over 2 at squared. So 0 times t automatically becomes 0. So s, being distance, is now 1 over 2 at squared. S is the distance covered. It was given to us as 40. So distance is 40 equal to 1 over 2. A is what we're looking for, which is acceleration. The time was given as 10. So you have 10 all squared. Okay. So this is 40 equal to 1 over 2 times a times 10 squared is 100. Okay, so 40 equals this becomes 100 a all over 2. Okay, so 40 is equal to 100 divided by 2 gives us 50 acceleration. So that simply means to make acceleration subject to the formula, divide both sides by the coefficient of acceleration, which is 50. So you simply have 40 divides by 50, and therefore acceleration A is equal to 40 divided by 50 is 0.80 meters per second squared. So the correct option is actually option C, 0.80 meters per second squared. Question 8 says the relationship between the linear expansivity alpha and volume expansivity gamma is. Option A says gamma, which is volume expansivity, is actually alpha, which is linear expansivity raised to power minus 3. Option B says gamma, which is volume expansivity, is equal to linear expansivity. Option C says 3 times linear expansivity, that is to say the volume expansivity is 3 times linear expansivity. Option D says the volume expansivity is equal to the linear expansivity to the power of 3. Okay, so this is a trick. Linear expansivity is always given as gamma, as alpha. Linear expansivity is given as alpha. So this is linear, simply means length. So it means the expansivity that takes place in a linear object. That's an object that has a length. Meanwhile, volume expansivity, okay, is actually gamma. We have the areal expansivity. Okay, which is beta. Now this is a trick. Area, just like the unit of area is usually meter square. Okay, unit of area is meter square. Unit of length is simply meter, while unit of volume is simply meter cube. So if the unit of length is meters, then the linear expansivity is an expansion that takes place in terms of length. Okay, meanwhile, if the unit of area is meter square, then area expansivity, which is beta, is actually, instead of saying squared, use the power to multiply the linear expansivity, so it's 2 times linear expansivity. So in terms of relationship, linear expansivity, area expansivity is 2 times linear expansivity. Also, since the unit of volume is meter cube, in terms of expansion, the volume expansivity, which is gamma, is actually use the power to multiply linear expansivity, 3 times linear expansivity. So this is actually the correct answer. Volume expansivity is simply 3 times linear expansivity, and the option there is option C, which is 3 times linear expansivity. Question 9 says, which of the following is not a consequence of hydrogen bubbles covering the copper plate of a primary cell? Alright, so I'm going to pause the video here and I'll post the options. Then when I come back, I'll give you the correct option. Alright, welcome back. The correct option is nothing but option C, local action. Local action is simply the process whereby a battery begins to discharge the current in it, even though the battery is not connected to an external source. That is local action. So it doesn't have to do with hydrogen bubble formation on doesn't have to do with hydrogen bubble formation on the copper plate of the primary cell. So the correct option is option C, local action. Question 10 says, a cell whose internal resistance is 0.55 ohm delivers a current of 4 amps to an external resistor. Question says, the lost voltage of the cell is. Okay, so we're given options. A says 4.0 volts, B says 2.20 volts, C says 0.15 volts, and D says 8.00 volts. All right, now to calculate the voltage lost by a device that has both internal and external resistor, naturally we are supposed to use V is equal to I R plus R, where the small arrow stands for the internal resistor and the bigger arrow stands for the external resistor. But in the question, the external resistor was not given, so we'll simply make use of V equal to I R. So we are simply calling the external resistor as 0. So voltage is equal to I is the current was given as 4 amperes. So we have 4 times the internal resistor was given as 0.55 ohms, so 0.55. So this means that the voltage is actually 2.22 volts. Okay, so on the options, we don't really have 2.22, but we have 2.20, so this is closer to the option. So the correct answer is actually option B, 2.20. All right guys, so I will pause the video here and we'll continue in the next video. I will continue from question 11 to question 20 in the next video, so it doesn't get too long and boring. All right, thanks guys. I hope you appreciate this video. Please do well to subscribe to the channel to get updates on when other courses like chemistry, mathematics will be released. Do well to subscribe. Thanks and stay safe.